Very good evening. In this session, we'll see something about roasting and calcination. See, first we concentrated was, right? We just saw in the earlier videos. Because we concentrated was by flotation, gravity separation, leaching, and magnetic separation. Depending upon the nature of ore, we concentrated it, right? See, after the concentration of the ore, we have to extract the crude metal. This extraction of crude metal usually takes place in two steps. In step one, the ore is converted into its oxide form, in whatever form it may be. It may be sulfide, it may be sulfate, it may be carbonate. In whatever form it may be, first it is converted into its oxide because it is easy to reduce an oxide. That's what we go for oxide. It is thermodynamically favorable, right? And then in step two, we convert the oxide into metal. So these are the two steps in the extract crude metal. Step one we say, right? In step one, what do we say? We convert the ore into its oxide form. So it is converted into its oxide form by any one of these processes. One is called by the name roasting and another one is called by the name calcination. First, let's see what is roasting. See, roasting refers to the heating of the ore in the presence of excess of air. We'll supply excess of air and we will heat the ore. When we do that, the sulfide will get converted into its oxide, right? When we supply a high temperature, we have to see to that it is below the melting point of the metal, right? Otherwise, the metal will melt. That's why we apply a melting point below the melting point of the metal. Okay, we'll just go for some examples. Let me go for screen sharing. Okay, hope you are able to see the screen. See, this is roasting, right? 2 PbS plus 3 O2 gives 2 PbO plus SO2. Here, galena is converted into its oxide form. Here we'll supply excess of air. And similarly, we take Zn as zinc sulfide. It is converted to zinc oxide. We take copper sulfide 2Cu2S plus 3O2. It gets converted to C2Cu2O plus 2SO2. So all these are sulfide ores. When I apply high temperature in the presence of excess of air, these are converted to the oxides. This process is referred to as roasting. Not only this takes place, some impurities will be there, which will be removed as their volatile oxides. See, for example, if I take arsenic, whose formula is going to be AS, it will be removed as arsenious oxide, As2O3. If I take sulfur, S8, it gets converted to sulfur dioxide, SO2. If I take phosphorus, it gets converted to phosphorus pentoxide, P4O10. So this is about roasting. So the sulfide ores are converted to oxide ores and some volatile metals are removed as their volatile oxides, right? We'll go for calcination. See, calcination is just the reverse of roasting. That is, here also we converted into an oxide ore, but there will say in roasting we supply excess of air, right? But this will be done in the presence of absence of air. So calcination is the process of heating the ore in the absence of air. That is what is referred to as calcination. See, for example, if I take PbCO3, one CO2 comes out of it, CO2. Apart from that, what we have? PbO. We take CaCO3, one molecule of carbon dioxide comes out, and we get CaO. We take ZnCO3, CO2 goes off, and have ZnO. Similarly, I take a double salt, MgCO3, CaCO3, two molecules of CO2 goes out, and I get magnesium oxide and calcium oxide. So, in all this process takes place in the absence of air. Therefore, the process is referred to as calcination. And here, in this process, if I have any extra water of hydration, that will be thrown out. See, for example, if we take Fe2O3.3H2O, it goes out as Fe2O3 plus 3H2O. Al2O3.2H2O gives Al2O3 plus 2H2O. Right? That's what we say in roasting and calcination. Thus, roasting and calcination, in both the process, we convert the ores into oxide form. But there are some differences. See, we have to differentiate roasting and calcination. We can say under roasting, all the sulfide ores are converted to oxides. Under calcination, we can say that the carbonate ores are converted to the oxides. Okay. Point number 2, roasting takes place in the presence of excess of air. In calcination, it takes place in the absence of air. Under roasting, we can say that the volatile impurities are removed as the oxides. And here we can say that any water of hydration present is expelled out. So these are the differences between roasting and calcination. So in both the process, we bring the ore into the oxide form. Okay, so from the oxide, we'll get the crude metal that we'll see in the coming videos. That's the end of the session. Thank you.